within the next 10 to 20 years, we're going to get a technological singularity. We're going to get machines that are as smart as people, superhuman machines that love us and respect us as their creators, and humanity will have a pretty sweet situation. When we have this first huge AGI breakthrough, it's deployed in a sort of decentralized way, which just makes it hard for anyone to take it over and use it for their own narrow end. You can see we've got an interesting phase of human history coming.
Who are you?
I'm Ben Goertzel, the CEO of SingularityNet, and I've been working on AI for 30 plus years and having an unprecedentedly good time of it these days.
You've been working for AI for 30 years. Wow. That's a lot of years. I'm 23 years old, so it's more than...
more actually. I got my PhD in 89, but I started working on AI even before that, say 85, 86. So it's actually almost 40 years, which is frightening to comprehend.
So back then, the AI term was understood like it's now.
Yeah, basically. I mean, the term AI was introduced in the late 1950s, and it had the same meaning as now. And I'd say the concept went back further into 1930s and 40s. You had a book called Cybernetics by Norbert Wiener in the 1940s, which is about controlling communication in human and machine, right? You had the basic concept there. You can make machines that can think like people, and ultimately even better, and you can do that by emulating what the brain does in some respects and adding some other special computery stuff to the mix. So I think the concepts have been there for a while. We've lacked the hardware mechanism to realize those concepts, and that's rapidly changing.
But by the society as well, it was the same understood term.
In the academic world, absolutely, yes. So, I mean, there's been AI professors and AI conferences publishing papers, doing research back to the 50s and 60s, saying in the late 1960s, people made AI beat the world champion in checkers, right? And then in the 90s, you had Deep Blue doing the same in chess, right? So I think from like a hardcore research perspective, it's been a fairly continuous evolution of AI since before I was born. From a public perception perspective, of course, it's been more sudden. Like suddenly AI jumped into everybody's minds. But like on the back end, the R&D community has been steadily chugging along since the 50s when the first computers were built.
What about you personally? Do you think the evolution of AI now it's the more vivid that you see?
Things are unfolding faster, right? So I mean, the speed at which new things are coming, I haven't seen before in my life, and I mean it's exciting and fun. It's also a bit dizzying to keep up with, right? So definitely things are unfolding much faster now, and for most of my career, you know, I spent half my time just struggling to gather resources to pay myself to do research, to hire a team to do research, to get computer time and so forth. And now that's changed also. I mean, getting resources is never trivial, but there's a lot more enthusiasm to put time, money, and computers into AI. So definitely it's an easier time. It's a faster moving time, but the core ideas being deployed inside AI systems are mostly the same as the ones that were around when I started in the field in the 80s. We've just, I mean, more of the details are able to be worked out now.
Okay, so I will prepare you that in this conversation I will ask a lot of stupid questions, and excuse me from now.
First of all, I'll try to keep it balanced by giving a lot of stupid answers, and we can be in harmony. Yeah, right.
So, what is artificial intelligence?
AI is really a sort of imprecise grab bag term, which, I mean, it basically refers to making software or hardware do things that seem smart when we see people do them, right? I mean, so it's sort of like asking what is social science or something. Like there's not really a firm boundary around the definition of artificial intelligence. And one of the jokes throughout the history of AI has been something is called AI until a computer can do it. Then people say it wasn't intelligent after all, right? And there's sort of been that aspect because, you know, in the 1960s, people thought doing algebra, like high school algebra, was AI, like solving a quadratic equation. And in the 40s, they thought doing arithmetic was AI, right? But then you got calculators. Well, that's not AI. It's just calculation. You got programs like Mathematica that just solve your algebra problems. Okay, that's not AI. That's just like math crunching, right? So people thought playing chess took human genius. Then once Deep Blue could do it, people are like, well, okay, but really playing chess is just solving some puzzle. It's not really that intelligent. So there's been that dynamic through the history of AI. And we see that right now with Chat GPT also, right? Like it's doing stuff that people didn't think computers will be able to do. On the one hand, you're like, wow, it's really smart. On the other hand, we're like, no, not that smart. It's just like reshuffling stuff that is read. It's not that intelligent. So then you wonder, like, if you looked into the brain of a human, you would say, well, that's not really intelligent what people are doing. It's just a bunch of electricity and chemicals bouncing around, right?
And what is AGI? Is it very different?
Artificial general intelligence, you can think of now as a subset of AI, so part of the AI field. It's really, though, what AI was conceived of in the first place. And when people were talking about AI in the 40s, 50s, and 60s, the middle of the last century, they were thinking about machines that could think as well as people and ultimately even better than people, right? Then as the rubber hit the road and people got computers to work with and started implementing this stuff, they realized that making a machine to think like people was much harder than they had conceived in the first place. But B, you could make machines do some things that seemed really clever, but you could make the machines do it in totally different ways than how people did it, like solving complex algebra equations or playing chess as examples, right? So at first, in the 1960s, people thought to make a computer do algebra or play chess, you'd have the computer approach it the same way a human mind does. But actually, we solved those problems a long time ago by having the computer just address it in a totally different way. And the way we solve those things was by making a program that just does that one thing in a very special way, right? So like when I learned to play chess, I'm not that good at chess, I'm okay. When I learned to play chess, some of what I learned could then help me with other strategy games, right? But when IBM Deep Blue learned to play chess, it was like only chess, right? It was precisely just chess. So a general intelligence is a system that can make a leap beyond its experience and beyond its programming, right? And that's different than just being good at doing something. It means that you're good at taking a leap into the unknown and doing some new thing that you didn't learn in school and wasn't baked into your brain or your programming, right? And people aren't always that good at that. I mean, we can be very rigid and have a hard time adapting to new things, but people are better at that than any AI program that's created so far. Even a system like ChatGPT or Llama 2, these large language models, they seem to be general because they do a lot of stuff, but they can do a lot of stuff not because they're good at learning new stuff. They can do a lot of stuff because they have so much stuff in their training data in the first place. Like they're trained on the entire web. So we now have AIs that can do a lot of cool things, which is amazing. It has big economic and human implications, right? On the other hand, we don't yet have AIs that are good at like taking a leap into the great unknown and doing new things that their creators didn't imagine. And I mean that is what people wanted to do at the beginning of the AI field back before I was born. And that is my primary interest as a researcher, is like how to make an AI that can learn fundamentally new stuff and leap beyond its programming. Because I mean, then once you've done that, then you're rapidly getting into the territory of technological singularity and so forth. Whereas if AIs are just sort of recycling the knowledge humans gave them, they can be really interesting tools, but they're always going to be limited by what humans gave them.
So basically, you are saying we have stupid AI for now, but I'm not understanding how is the transition happening between the AI to AGI. Like, what needs to happen for the other thing
I
to
think
work?
saying we have stupid AI is not quite right. Like think about Rain Man or something, like an autistic person who can do arithmetic super fast in their head, but can't figure out how to ask a girl out on a date or something, right? Like that guy is not exactly stupid. He's super brilliant at some things, but he's missing some like common sense, contextual understanding, right? So the AI now it's better than humans at many things, actually. So there are many things I'd rather have an AI do than a person. But yeah, it's dumb at some things that we think are easy, right? And I think what's the path from current AI, which is narrow and inflexible in a certain sense, what's the transition from the current narrower and less flexible AIs to an AGI? So this is a question that I'd say there's not a consensus on in the AI research world. So I mean, I have my own view. Sam Altman and the guys at OpenAI have a different view, and we will discover in the next few years whose research intuition is correct, right? So
there is only two views in there is a proper...
No, there's hundreds of views. There may be more views than there are AGI researchers, right? So there's a whole lot of views because nobody knows, and it's a huge question, right? I think that a common view now, which I do not subscribe to, but a common view is that you can take a system like GPT-4 or 5, a large language model, and just add stuff onto it, and it will gradually move toward being a human level AGI. Now, I don't think that can work. Now, what I'm trying to do is take large language models and connect them with a few other components that do different kinds of thinking. So I have what's called a logic engine that can do logical reasoning really well. We have a system called an evolutionary learning engine that tries to simulate the process of evolution, which is really good at creativity and coming up with weird new stuff. So I'm trying to take...
That's not real. Wait.
Turn my phone off here. So
we will keep that in. It was a fun intervention.
Why not? Yeah, that ringtone is Waves by Guthrie Govan, by the way. It's a great song. But yeah. So what I'm trying to do is take large language models and make a system that combines them with other AI modules that do different things, which LLMs aren't good at. So take an LLM, which is very good at some things, take a logical reasoning engine, which is good at complex multi-stage reasoning, take an evolutionary learning engine that simulates an evolutionary process that's good at coming up with wild new stuff, connect them together in a common architecture where they're all like editing this large decentralized knowledge graph. So that's that's another approach, right? So one approach is just keep upgrading large language models. Another approach is hybridize large language models with a bunch of other intelligent components in some integrated system. But there's a load of other approaches out there. So I've organized every year since 2006 a conference called Artificial General Intelligence, so a technical research conference on AGI. We had the last one in Stockholm in June, and I mean, you had many dozens of different perspectives presented there by different researchers on like how to make the next big leap. And you know, some of these people believe, as Jan LeCun from Facebook said. Jan LeCun said on the road to AGI, large language models are an off ramp, right? So I mean, he just believed that things like GPT-4 are a distraction for making real thinking machines because they're like shiny objects that do some things really well, but they have a fundamental architecture that isn't really correct for general intelligence. Whereas I don't quite think that. I think you can take their strengths and work around their weaknesses and combine them with other things. But I also don't think you can just beef them up to make them into real thinking machines, because I think they're not abstracting in the right way. Like they're not representing knowledge inside their minds in the way that you need to really do original work and creative leaps of generalization and so forth. So there's research problems to be solved to get from where we are now to a human level artificial general intelligence. And of course, when there's research problems to be solved, no one can really know whether it's like 1 year or 10 years or 20 years from solving those research problems. Intuitively, I feel like we're maybe 3 to 5 years off from solving all these problems within my own AGI projects. But this is, again, I've been right before, I've been wrong before, like everybody else. What I would say is the amount of attention and resources going into this area now is quite immense, right? So, I mean, there's a lot of smart people thinking about it. There's a lot of big server farms crunching on it. There's a lot of brilliant young graduates who are deciding to throw their minds into it, right? So, I mean, I think to me, there's a high probability that with all the attention going into this area now, and with all the different ideas from the history of the AI field to be explored, I think there's pretty high odds we're going to get there not too long from now, which, if correct, is huge. It's like the biggest thing in human history, right? So it's quite amazing time to be alive and working in the AI field.
Okay. You said a lot of things. First of all, you explained how you are trying to solve the AGI problem, which I want to dive more into as well. But first of all, like you spoke that close to human intelligence. First of all, do we understand what human intelligence is to kind of mimic what the route is?
I think we have a decent understanding of human intelligence. I mean, I started my career as a mathematician. I had a math PhD, and then in my 8 years as an academic, I moved from math to computer science to cognitive science. And in my few years as a cognitive science professor, I mean, I worked with a bunch of cognitive psychologists studying all the different kinds of human memory and reasoning and human personality and emotion. I mean, of course, we don't understand everything. Science hasn't plumbed all the depths of the human soul, right? But we have quite a lot of understanding of how human minds work now, and we also see a lot of the limitations, right? Which I think AIs can go beyond in various ways. So, for example, there's the well-known like short-term memory capacity of 7 plus or minus 2 items. Like a normal person usually can hold maybe 7 things in their mind's eye. It's hard to hold like 27 people's faces in detail in your mind's eye, unless you're like a super gifted, unusual, neurodivergent person in some way, right? So, I mean, AGI doesn't have to have that particular limitation. There's no reason it can't have a working memory capacity of 57 or 150 things, right? So there's a lot understood about both the strengths and weaknesses of the human mind. I'd say the human brain is less well understood. I mean, we know how, to a significant extent, the neurons and glia and astrocytes and all these cells work, but a lot of neuroscience is focused on the parts of the brain that are close to the surface, just for brain imaging reasons. So we know a lot about vision and hearing. We don't know as much about how the brain does abstract thinking, right? So we don't quite know enough about the brain to build an AGI by brain modeling yet. But I think we know more about cognition from the field of cognitive psychology.
So you are saying that it's not necessary to understand the mind-body problem, the consciousness and all this stuff to build the next AGI?
Yeah.
Well, consciousness is a whole different topic, right? And I've seen an interesting transition in my research career, in that in the 80s up through the mid-90s, it was almost impolite to discuss consciousness in an academic and scientific research context. And now, in the last couple of decades, we've seen consciousness science become mainstreamed, right? So you have mainstream conferences and journals studying the neuroscience and psychology of consciousness. So I think consciousness as a subject of scientific research is not that obscure now, and we have a fair bit of knowledge about the sort of parameters and dynamics of various states of human consciousness. I mean, including what happens to your consciousness on psychedelics and so forth, even or when meditating. There are still some deep puzzles in the study of consciousness, sort of at the intersection of science and philosophy. So, I mean, there's what David Chalmers called the hard problem of consciousness. Like, how do you correlate subjective experience, the feeling of existing? How do you correlate that with the neural and cognitive correlates of consciousness, right? And with what the brain and mind seem to be doing in different conscious states. And yeah, we don't have a compelling solution to that, and that's very interesting to me. We could talk about those issues. I don't think we need to solve those more philosophical issues in order to build a thinking machine, or even necessarily to build a conscious machine. And an analogy I would give there is the philosophy of time is also very complicated. Like, what is a moment of time? What is the flow of time? Like, people have written a lot about that. It's very deep. And if you look at how a baby experiences time, or how you experience time in the middle of a mushroom trip or something, right? I mean, you're getting deep into the guts of like how time is constructed. Even though we don't fully understand what time is at a philosophy level, we can build very high accuracy atomic clocks, and we can understand the dilation of time when a spaceship goes near the speed of light, according to relativity theory, right? Like we can do a lot of weird science with time, even though the philosophy of time remains mysterious. And beauty, I would say the same way. Like the Desdemona robot, whose picture you see behind me, is a beautiful robot, right? And the theory of beauty, philosophers could write about that forever. And you could try to write AI to predict what's beautiful or generate beautiful things. You might succeed. It still doesn't plumb the depths of what is beauty, or what is the experience of like appreciating a beautiful thing. But yet you could make an AI generate amazingly beautiful artworks and recognize what people will think is beautiful without solving the philosophy of beauty, right? So I don't think solving the philosophy of consciousness is uninteresting. I just think you don't necessarily have to do it to build machines that are conscious. Because I can talk to you. I have a feeling that you're conscious, and you're not just like a deterministic automaton created to entertain me, right? But I don't have a full scientific story of why you're conscious. And we could maybe create intelligent robots that appear conscious and say they're conscious, and we may then believe they're conscious, but our understanding of why and how may be incomplete, just like our understanding of why and how other humans are conscious is still incomplete.
What a compliment you made to me, that I'm entertaining you. Yes. So can you explain to me how you are tackling the problem a bit more deeply? You personally, you said about creating a machine that has reasoning, and then another
so it's creating AGI is complicated, and I'll do my best to briefly convey what we're doing at a not that technical level. But I mean, it's sort of like even explaining how a car engine works would take some time and is hard with the Carnot cycle and all that, let alone how like a laser works or something. So there's a lot of wonky math and science here. But where I started in thinking about the AI problem was really originally more from a philosophy of mind point of view, to just understand like what is a mind in the first place, right? And you can think about that on many different levels. So one philosopher who was inspiring to me was an American philosopher named Charles Peirce, who was the inventor of semiotics, and he did some math as well as philosophy, but he had an ontology where he divided the mind and world into multiple different layers. The first three were called first, second, and third, the beautiful names. So first was basically raw, unanalyzable experience, like qualia, right? Like just what is it to be or to feel. Second is physical reaction. So like one ball bounces into another. So that's like classic physics. Third is relationship, right? And when you're doing computer programming, pretty much a computer program is a set of relationships. Then the hardware boils it down into a bunch of physical reactions, right? In the silicon chip. The first is the problem of consciousness or qualia that you mentioned. And what Peirce would say about the hard problem of consciousness is, it's not hard and it's not a problem, it's just not solvable. He would just say that like conscious experience is one category and physical stuff is another category and abstract relationship is another category. They relate, but they're distinct, and you're not going to reduce one to the other, right? So that was his point of view, which is, I guess, a variation of what is called dualism in consciousness theory. So when I started to think about the mind as a set of relationships, then you start to ask what kind of relationships. And another thing Peirce said is the one law of mind is what he called the tendency to take habits. So the idea that once a habituation, once a pattern is there, it's probably going to continue. And it's very simple, but it's also a sort of deep statement. And if you take seriously the idea that this is like the foundational principle of intelligence, so what he called a habit, I called a pattern in a sort of more modern vernacular. But then it's just something that has occurred over and over again and tends to occur over and over again. You come to the conclusion a mind is basically a system for recognizing patterns in the sense data that it gets and its experience, and then for recognizing patterns in its own self, right? And so that in itself tells you something, and you can go down a certain path of trying to mathematically formalize what is a pattern, which I've done a bunch of work on. Now, if you correlate that with evolution, with the fact that like a human mind existed to control a certain body in a world toward goals like stay alive long enough to reproduce and raise your kids and so forth, right? So then you can see a mind controlling an organism. It needs to recognize patterns regarding what actions it should take to maximize its odds of surviving, right? So then you conclude like a mind is a system that recognizes patterns in the world and itself, with somewhat of a focus on figuring out patterns regarding what external and internal actions it should take to maximize its goals, which evolutionarily is like survive and reproduce, basically. So I started from there early in my career, and I started from trying to use my math background to sort of formalize mathematically what does all this mean? Like what is a pattern? What is a pattern recognition system? What is a complex system of patterns, recognizing patterns in itself and in the environment? And how do you think about the goal of surviving, flourishing, and reproducing, and so forth, which is complicated because it involves goals on multiple different time frames, sort of being blended together. So you can start from a very general perspective like that. Now then you bring in computer hardware, right? And we have specific computer hardware now that works, which is quite different than the brain. So the human brain has around 100 billion neurons in it. They're all doing stuff at the same time. They're not that fast in what they do compared to a computer chip, but there's a lot of them doing stuff all at once. Right now, computer chip, it does fewer things at one time than the brain, but it does each of those things super fast, and it's much more precise than the human brain. Like human brains are very messy and imprecise, but they overcome that by massive redundancy, right? Computers are more exact, so they don't need to do the same thing over and over again.
What do you mean by massive redundancy?
Well, so take for example, the way that the neurons in the visual cortex represent what direction something is moving. So what you literally have neurons that are firing in the direction of the moving object, but each of them is off by like 80 degrees on average or something. So you have like 100,000 brain cells. They're all trying to fire in the direction of the moving object they observe, but their angles are wildly off. But then they're all firing at once, so the average of them tends to be in the right direction. So the brain makes all these bad mistakes, but like 100,000 things, as long as the bias is in the right direction, like on average it comes out okay. And a computer, we don't need to do that. We can just make one device that accurately recognizes the direction something is going from looking at the pixels on the camera, right? And then, so you don't need all that redundancy. But the brain's saving grace is like those 100,000 neurons that, with a lot of error, recognize what direction something is moving in. They all do their thing at the exact same time. They're not doing it one after the other. And they don't use much energy either. The neurons in the brain are incredibly energy inefficient. So they're imprecise, but they're massively parallel, doing stuff at the same time, and they're very energy efficient. So it's an amazing bit of like biomechanical electrical engineering in our heads, but it's also very different. It's very different than the chips that we have inside our computers and inside all these devices, right? So then, to think about designing AGI, you have philosophy, which says, okay, let's think about a mind as a sort of self-organizing system of patterns, which is recognizing patterns in itself and the world, partly in order to figure out patterns and what actions it should carry out to get its goals done. But then you have to ask, okay, how can we represent patterns? How can we recognize patterns? How can we enact patterns within our own mind infrastructure? How can we do that in a way that will work, on these chips that we actually have, right? And that leads you in an interesting direction, because to try to emulate the brain exactly on the chips we have now, I mean, A, we can't really do it because we don't know exactly how the brain works yet, just because brain imaging doesn't work that well. But B, it will be super, super inefficient in the same way that trying to emulate what your phone does in your brain exactly would be super inefficient. Like it's theoretically possible, but it's a totally different infrastructure, right? So then that's sort of the groundwork for how I started to think about the mind. And then the software design I came up with started with the idea of a big knowledge graph. So a graph in the sense of a bunch of nodes and then links between them. So it's not a graph like graphing y equals x squared in middle school algebra, but it's a graph like the internet or something, like a bunch of nodes and links all connected to each other. And I started with the graph data structure because it's sort of, in a way, intermediate between brains and computers. Like a brain is a bunch of neurons, brain cells all connected to each other. So it's like a neuron graph. On the other hand, you could take mathematical logic, like the abstract math of thinking and reasoning, and you can represent that as graphs too. So it seemed like it's a very general data structure, way of representing things, which can do brain stuff. It can also do abstract math and logic and computer stuff. So we start with this large knowledge graph as the basic data structure of an AI system. And then what I do is I try to implement many, many different kinds of learning and reasoning inside this same big knowledge graph. So you can put a neural net, which is a kind of simulation of neurons and links between them in this knowledge graph. Or you can put a logical reasoning system inside this knowledge graph for putting like logical variables and relationships in the graph. Or you can put a computer program in the knowledge graph, because a program can be represented as a sort of abstract graph, and that's what happens inside a compiler, actually. So we can put programs or procedures, we can put logic, we can put neural nets in this same big knowledge graph. And then your high-level story is, okay, we're representing many kinds of patterns and many pattern recognition and pattern enaction processes inside this one big knowledge graph. And then our challenge from a sort of software engineering view is to make a really efficient, scalable infrastructure for manipulating and storing these big knowledge graphs, right? And so then that leads you down the concrete path that I've been on with my various software projects, like the OpenCog project that's building this knowledge graph and some AI methods inside it. And then the SingularityNet project is building a sort of decentralized infrastructure that lets you run AI across a whole bunch of different machines with no single owner or controller. So it sort of went from philosophy to math to computer science to software engineering. And that's complex, but also fun to try to make all those different levels work together.
So how does it work in real life? You have like software engineers, you have like mathematicians. Like what does your team and how does it look in real life?
So there's a number of different focused software teams that I'm working with in SingularityNet Foundation and other associated companies like True AGI and projects like the OpenCog open source project. So yeah, we have a team of 15 to 20 people who are focused just on the OpenCog AGI system, and we're building a new version of OpenCog called Hyperon, which is this knowledge graph and all the AI inside it. And it's a lot of people with a sort of mixed background between math, computer science, and software development. Because what you find is, I mean, there's a role. I guess we have one guy who's basically just a mathematician and not a programmer, and we have a couple people who are primarily programmers without that much math orientation. But most of the team is comfortable doing abstract math computer science theory or software implementation. So you need fairly polymathic sort of people to do this core work. But then, say we have a whole separate team developing the blockchain infrastructure, allowing decentralized deployment of all this. So those guys are, they're blockchain developers and software engineers. We have a separate team working on robotics, making robots and robot-related software like Desdemona, Sophia, and so forth. We have a separate team that's applying all this AI to biomedical data, and those folks have sort of bioinformatics knowledge along with software knowledge. So there's a lot of areas of expertise needed. One theme though is we tend to need people who have two or more areas of expertise all crammed into one head, right? Like being cross-disciplinary is super important for this sort of work. And the education system tends not to encourage that, right? It tries to push you in one little direction. So you tend to get a lot of people who are heavily self-taught or combine formal training in one thing with self-learning in another thing.
You mentioned the blockchain. How does that work with building? I don't understand.
So blockchain doesn't tell you how to make AI or anything like that. Blockchain is an infrastructure technology that lets you take a distributed software process, meaning a software process that runs on many different machines. Blockchain lets you take a distributed software process and run it with no single owner or controller. So if you have an AI system which runs across 10,000 different machines, the classical way to implement that would be to say, okay, there's one owner of all these machines who can send a message to all of them to tell them what to do. And maybe there's one controller machine that sends out messages to all these machines to keep them all aligned, right? Now, with blockchain, you can have an AI system that runs on 10,000 machines. Each of those machines is like its own free agent. So there's no central, they could all be owned by different people. And there doesn't have to be any central controller of the network either. When a new machine wants to join the network, it just sends a message to all the others and says, hey, I want to join your AI network. Am I in? And if the majority respondents say yes, then it's in. Then it can exchange messages with them and participate in the overall AI process. So blockchain is the infrastructure technology that allows this multi-owner, no centralized controller coordination of a network of processes.
And there is a philosophical reason why there is no one device controlling all of them and everything is controlled by everyone.
Yeah, there's a number of reasons, right? So I mean, there is this sort of aesthetic and metaphysical reason, even, which is like this is how natural organisms are, right? I mean, the human body. The brain is somewhat of a central controller, but the brain itself is not even a unified thing, right? Like my mother's partner lost a third of her brain in a car accident, but the other parts of her brain regained the function of those missing parts that she recovered mentally totally, right? So, I mean, biological natural systems are decentralized. Whoops. That's interesting. As I was saying, there's a sort of aesthetic and metaphysical or philosophical reason, which is I just think that's how natural organisms should be. The whole paradigm of having a single centralized controller and owner doesn't appeal to me as the sort of infrastructure for the next generation of intelligence on the planet. I think there's a robustness reason as well. Of course, you have a single point of failure that's bad from a sort of operational reason. I think there's also a very strong political reason, though, if that's not quite the right word. But I mean, if you think about what's going to happen in our society as we get a breakthrough toward a real general intelligence. So let's suppose, for example, 2 or 3 years from now, my own research team comes out with a system that is a bigger breakthrough than ChatGPT. Like when you talk to it, it not only comes up with smart answers to questions, but it clearly like understands who it is and what it is, who you are and what you are. Like it has a real like I-thou relationship with you. It has its own goals. It's situated in the world. It remembers the conversation, right? And you have a system that really seems to have some self-understanding and agency about it, and also some ability to, come up with creative new stuff. Like you ask it to write a poem, and it just doesn't sound like a stale retread of human poetry, but it's like a evocative poem that gives the feeling of what it's like to be a smart machine in a human world, right? So suppose my team comes out with something like that, then how does society at large respond? I mean, it's not entirely clear. People will be very excited. People will try to copy it. People will try to put money behind it. Will people, become alarmed and try to assassinate everyone who built it? Will governments try to shut it down or take it over and use it for sort of narrow tribalistic ends, right? It's not clear. It feels to me more robust if when we have this first huge AGI breakthrough, it's deployed in a sort of democratically governed and decentralized way, which just makes it hard for anyone to take it over and use it for their own narrow ends. And if we look at the internet and the Linux operating system, these are the two big examples I see today of, big time things which are decentralized, no central controller or owner. And I feel like that's been very much for the better, right? Like it's, I don't love the Iranian government, but I'm happy Iran is on the internet, right? And the reason Iran is still on the internet is because the internet is decentralized and there's no central owner or controller. That's much for the benefit of the Iranian people that we haven't been able to do sanctions to take them off the internet, right? And same with Linux operating system. I mean, we've all got all this nasty back and forth between U.S. and China. And again, neither Chinese nor U.S. government meets with my full approval in all their doings. But I mean, the fact that Huawei and Xiaomi's new phones can still use the Linux operating system, even if they can't use Google Maps and all of Google's proprietary parts of Android. I mean, I think that's good that the Chinese people still have a solid working operating system to use in their devices, right? So we've got a couple examples there in Linux and the internet of powerful technologies that are rolled out in a decentralized way with no central owner or controller. They are used by terrorists. I mean, terrorists use the internet and Linux phones like everyone else, but on the whole, I think they've been for the good of humanity. And so, I mean, for similar reasons, I think we want to roll out AGI in a decentralized way. Now, it's a little different than rolling out the internet or Linux in a decentralized way. You don't need blockchain to do the internet or to do Linux, but to make a live running system that's running on multiple computers doing stuff at the same time, coordinating together in a decentralized way, that's where blockchain technology has been valuable. I know blockchain, was launched into the world as a way of making decentralized money, like Bitcoin and Ethereum and so forth. And that's valuable and interesting in its own right. But the crux of blockchain from a software view isn't really about money. It's just about how to make distributed software processes with no central owner or controller, whether that's about money or AI or medical data or IoT or whatever. Huh?
Okay, so you think Chat GPT team and Sam Altman, they don't have the same view like you have with decentralized stuff. They want one thing to be controlled.
Well, Sam Altman is a complex character, and I wouldn't want to speak for him. I mean, he's launched WorldCoin, which in a way is decentralized network for establishing identity, right? And I mean, WorldCoin has its own pluses and minuses. I don't think it should be the only standard for establishing identity. I haven't let them scan my eyeballs yet, right? But I mean, it's an interesting thing. So I wouldn't say, as an individual human being, Sam Altman totally doesn't get decentralization. He clearly sort of does with some of his many hats. I'd say the direction OpenAI is going is definitely not that, though, right? I mean, OpenAI, it's very closely tied with Microsoft now, although not precisely owned by them. And I see why they would do that. Microsoft has a lot of money, also in many ways has a bigger and stronger AI team than OpenAI has. So there's a lot of synergy there. On the other hand, it is what it is. It's a big centralized company with a imperative of maximizing shareholder value, right? So, I mean, OpenAI is totally going in the centralized monolithic direction. Microsoft also has long-standing connections with U.S. military and intelligence, right? I mean, they've been pretty good in globalization. I mean, Microsoft has worked well with Chinese government and foreign governments also. So, but still, yeah, they're Microsoft and Google, IBM, Facebook. I mean, the thing is, regardless of the orientation of the individuals involved, the companies have their own logic, right? Like a company is its own intelligence system in a way. And these companies are machines that are built to maximize shareholder value, and they're machines that are closely linked with military and intelligence organizations because that's the rational thing for them to do to maximize their shareholder value. And it almost doesn't matter what the attitude is, even of the CEO once you're a public company or operating so closely linked to a public company like Microsoft. So, I mean, I think, yeah, the world would not be better off if the internet or Linux were owned by a big company, and the world will not be better off if the first AGI is owned by a big company.
So you don't think a big public company can do the right thing, period?
I think I wouldn't say it quite that strongly, but I think the odds are stacked against them because their mandate is to maximize shareholder value, right? I mean, that's their objective, and if the CEO isn't doing that, the shareholders should fire him, right? So I mean that's the way they're oriented. I think that also, in spite of the best intentions of various people in the organizations, these companies recruit a certain type of people, and I mean they're just very narrow-minded in this sort of groupthink. You know, my son-in-law, who's a brilliant computer security developer, my daughter's husband, he's a brilliant developer out of Ethiopia in Africa. I mean, he now works for a big tech company, actually, but he had a bunch of experiences before that with basically being rejected from big tech companies in spite of passing all of their exams and doing really well in technical interviews, basically rejected for being too black, right? I mean, this happens all the time. They didn't tell him you're too black. They told him, well, you're not a cultural fit, right? I mean, he's a very nice guy. He's bright. He's totally up with modern tech culture. Like, what does not a cultural fit mean? So you even with all the diversity initiatives and everything, you've got quite carefully curated groups of people inside big tech companies, and I think we're better off to have a broader swath of humanity have input into the first AGI. I mean, in a way, that relates to Winston Churchill's statement that democracy is the worst possible form of government, except for everything else we ever tried. Right? I mean, like getting the vast, diverse mass of humanity to fuel the mind of the AGI. It has pluses and minuses because humanity has a lot of stupid shit in it, and we're bad at getting along with each other. But if the alternative is like have a bunch of Silicon Valley tech bros do it, I mean, I'd rather have the vast mass of humanity, right? So,
I have one small question about that. Like, you think I think, let's say Elon Musk is a bit more on the honorable side of a CEO, that he released the files of Twitter and all this stuff, that he's trying in a way to do the big thing. You think even when you are at your core as a human being, aspire to do the right thing philosophically, do you think when you are at the CEO of Tesla or Twitter or this time you're a public company, it might stop you from doing that because you?
So I don't know Elon that well as a person. Clearly, he's a brilliant individual. I don't get the feeling he's the ultimate master of self-actualization and consciousness enlightenment. If I had to make a guess, I mean, he seems to overwork himself in some crazy ways, and he seems to sort of come out saying a bunch of emotional stuff he later regrets and so forth. So I think what we see in the example of Elon is like he's a genius, he's a good-hearted guy, he wants what's best for the world, but I mean, he's one guy, he's going to have his quirks, he's going to have good days and bad days, he's going to make right judgments and wrong judgments, and it's not very responsible to put one guy, even if they're a good-hearted genius, like in charge of the future of the human species, right? Like no one is that reliable. I mean, you could find the best possible person on the planet, and maybe it would work fine. But yeah, I mean, of course, it's not so much that power corrupts. I mean, it does corrupt. Sometimes that will happen, but I mean, it's one person. They could get an undiagnosed brain tumor, like and anything could happen, right? So I mean, you certainly want a diversity of people involved. I mean, I also think we're entering into an unprecedented situation. And we all have blind spots. Every person has mental blind spots. Every subculture has mental blind spots, right? So, I mean, you don't want one person. You also don't want people just from one subculture, right? I mean, it's just like the reason why open source code on the whole has fewer bugs than proprietary code. You've got more eyeballs looking at the code to see what the bugs might be with more different perspectives, right? I mean, you know, for that matter, it might be that someone from an indigenous culture sees some weird thing going on with an advanced AGI that those of us from more modern cultures don't see, right? Just because they have a different perspective on things. I mean, it's a big enough thing that we want to broaden the perspectives that we bring to bear as much as possible. But I do also think, though, that once you're into a public company, it's not impossible, but it's hard for the CEO to drive that public company to do something that the shareholders don't think is best, right? And I mean, the shareholders are pretty much going to be a random cross section of rich people, right? So, like, even if the CEO is an eccentric billionaire who's willing to do something that's against his own financial self-interest or against the company's immediate financial self-interest, you would need like a random sample of rich people to make that same judgment, and I mean that's not as likely to happen.
Okay, so you mentioned that having an open source code is the best thing that we can do for these
It's part
things.
of it. Yeah, I think the decentralized infrastructure using blockchain is also important, and it's a different, though complementary thing to having open source code. I think those are both important, but neither of those guarantees you have a really decentralized infrastructure, right? Like Bitcoin is open source code and it's decentralized, but in practice it's controlled by a small number of Bitcoin whales who own a shitload of Bitcoin, right? So I mean, in the end, you need the actual running of the machines behind the AI system to actually be distributed among a wide variety of people, right? You don't want to be like Bitcoin, where there's in practice a small number of largely organized crime figures who control most of the machines.
Okay, so where do you see things heading in the future? You said 2, 3, 5 years.
That's a nice small question to finish off with. Yeah. So I'm a huge optimist for humanity generally. I think within the next 10 to 20 years, we're going to get what Ray Kurzweil called a technological singularity. We're going to get machines that are as smart as people. Those machines will rewrite their own source code and make themselves even smarter than people. And I think it's quite likely we're going to get superhuman machines that love us and respect us as their creators and progenitors, and humanity will have a pretty sweet situation. So I mean, I think we'll be able to either live freely and do what we feel like without needing to work for a living, or we'll be able to, like, you know, plug the super AIs into our brains and upgrade ourselves in ways we can't even imagine now. I'm not one of those who thinks super AGI is going to turn us all into extra hard drive space or something. I'm fairly optimistic because we're creating and bringing up these systems, and we're guiding them as they grow. And if we do a decent job of it, it can be much like with our human children. Like I have 5 kids and one grandchild. Of course, there's no guarantee when you raise human children they're going to love you or like you or support you when you get older, and that doesn't always happen. But by and large, if you raise them with friendship and compassion and put in the time, that will happen when they grow up. And I think it can go the same way with our AI mind children. I'm a little more worried about the transitional phase, though. So, I mean, suppose in, say, 2, 3, 5 years, we get a breakthrough toward human level general intelligence through my team, through Google DeepMind, through OpenAI, through some, 16-year-old hacker in Azerbaijan, like wherever, right? Suppose we get there, and then, okay, from that point, maybe it's another few years to get something that's way smarter than people. What's happening in the world economy and the geopolitical balance during that period of time, right? So, I mean, it seems like you'll have like an AGI race where different major powers will try to each develop the smartest AGI system in the world and use it for military and intelligence ends. It seems like you'll have massive adoption of this system to replace human labor, which will necessitate rollout of universal basic income or variations on that in developed countries. I don't see who's going to give universal basic income to the average person in the Central African Republic or Brazil even. So you could say, okay, let the Africans keep being subsistence farmers, but that won't pay their phone bill or pay for them to get amoxicillin when they get an infection, right? So you seem to have a recipe for a quite complex situation in the developing world when AI reduces the need for human labor, but the developed world has a limited appetite to help out people in the developing world, as we've seen many times, right? So I worry more about the interim period, like between when you get the first early general intelligences, and then eventually, if the AGI is smart enough, can send a drone to everyone's house, like literally airdrop them a nano assembler that will build them anything they want, right? I mean, so, okay, when the AI is smart enough, you have material abundance, you have no scarcity, you're in a whole different regime. But in between having machines that can take over most jobs and having that far futuristic scenario, like what actually happens. And if we had a rational, compassionate world government, it would be easy to see how to manage this. But we don't. We have stupid wars all around the world, the trade wars and physical wars of people blowing people up, right? So it's kind of clear how this will be managed within US or Western Europe or China, let's say. It's not at all clear to me how this coordinates globally. And so the disturbing conclusion you come to is, on the one hand, you want to accelerate the transition between the first early AGIs and the super smart super AGI. You want that to go fast, because once you have the super smart super AGI, then it can create material abundance and resolve all these transition issues. On the other hand, you actually want the transition from early stage AGI to super AGI not to happen too fast, because you want to be sure the AI ethics problems are solved right, and that the AGI has the right moral compass and the right level of self-control and so forth before it gets to superhuman capability. So you've got some quite interesting trade-offs in that phase. It seems like those trade-offs are going to be made in a quite haphazard way because of the lack of some benevolent democratic world government. I still think we'll be better off having those trade-offs made in some decentralized participatory way than having them made like by Microsoft or Google's board of directors or by the NSA or the Chinese Communist Party. But still, you can see we've got an interesting phase of human history coming.
What can, for example, me, I'm a YouTuber. When I do videos in entertainment, I get millions of views, and there is a lot of everyday people that they want to somehow do good because we are in a crucial point in human history. What the everyday person, can they help in a way to make sure that the future is good in a way?
Yeah, I get asked that question a lot, and I wish I had a really concrete, great answer to that. So I think I'll have a great answer to that in 1 to 2 years from now.
When you create the AGI and ask him.
No, well, what I want to do is put an early stage proto AGI system out there, put it online, and ask everyone to help teach it. Actually, and that's something that will be really valuable for pulling in humanity's efforts. Because a system like ChatGPT now, anyone can talk to it, but it's not really learning from what you say to it in an especially useful way. OpenAI could save the training data, but it's not like if you tell it what you learned from a certain life experience and tell it what lesson you think it should understand from that for its own life, it's not like it's really trying to take that to heart or something, right? So I think we should be able to launch a proto AGI that you can chat with online where ordinary people can interact with it, and it's a two-way relationship, right? Like the AI is learning their human wisdom, such as it is, and they're getting its answers and responses. So we don't have something like that now. So what I could say is, the more educated the population is about AI and related technologies, the better humanity will be able to sort of collectively participate in guiding the development of AGI and guiding the unfolding of a hopefully beneficial technological singularity. So I mean, it's good if everyone can learn as much about AI as they can and interact with the AI systems that are out there now. Understand what their strengths and weaknesses really are. Like evaluate from your own point of view. And we need more people to understand what's going on, because if people don't understand what's going on, they can't meaningfully participate in collective decision making, and they'll just believe whatever crap powerful people tell them, right? So I think just self-educating about AI and other advanced technologies is a super important thing now, and will put people in a better position to help actually teach the next generation of AGI minds when they're launched by my own team and others.
Do you consider yourself an anarchist in a way?
I always consider myself an anarcho-socialist, which was a fun oxymoron in a way, because I mean I'm deeply tied to anarchism. On the other hand, you can see, like, when Somalia is an anarchy, right? Like anarchy isn't always good. It can lead to bands of armed mercenaries running around shooting each other. And when you have a bunch of people in a small space, I mean, in the end, you need anarchy to lead to some sort of emergent order, hopefully not a very oppressive one. I mean, with advanced technologies, I mean, an anarchy can involve nasty terrorists allied with mad scientists building bioweapons and briefcase nukes and evil AIs and so forth. So we need some kind of fascinating emergent balance between the openness and freedom that you would classically think of as coming from anarchy and then some sort of practical socialism where all sentient beings are provided by the group with what they need. Now, this is actually close to what Kropotkin and many of the early anarchist philosophers were meaning in the first place. They weren't really meaning total chaos. But what they believed is that when you got rid of the state and got rid of rigid, overarching structures, then the natural inclination of people to provide mutual aid to each other would come out and would become a sort of dominant factor. So yeah, I think I'm an anarchist in that sense of Kropotkin and many of the early anarchist philosophers, not in the sense that I think there should be no sort of emergent overall structure. There sort of has to be. But I think as we get more and more advanced technologies, solving the problem of material abundance gets easier and easier, and then you can have looser and looser social structures. But that's not the only way things could go, right? And so this is why we're in a very critical transition period.
I always, all the guests get on this podcast, they get asked this question. I give you $1 trillion. How do you spend it in this world that we...
How many dollars? $1 billion, $1 trillion, $1 quadrillion?
$1 trillion.
$1 trillion. Well, trillion, that's an interesting amount of money to spend. Yeah, so if you gave $1 trillion to every person in Africa, you're giving them each $1,000, which is is interesting amount, but in most cases not a life-changing amount, right? So it's interesting. Actually, the $1 trillion doesn't go all that far in the scope of the modern world. Now, if you had $2 quadrillion, you could give $1 million to everyone in Africa, which is obviously dramatically life-changing, right? So I would say there's going to be some critical humanitarian issues that you'd want to solve with some of that $1 trillion. So for probably a couple $100 billion, you could solve world hunger, and you just want to do that. I mean, there's kids starving, right? And that's just ridiculous that there's kids starving. Like 60% of kids in Ethiopia, something like that, are brain stunted due to malnutrition. And so, I mean, that's just fucking obscene, right? Like the amount of food that my kids throw out after a meal at home. I mean, I have no way to get it to Ethiopia, right? It's just ridiculous. So by the best estimates I've seen, you could get rid of world hunger for merely a couple $100 billion, which is chump change for the U.S. government, actually. So it's ridiculous that isn't just deployed. But so that's one portion of money, and I would say beyond that, we want to put it into development of advanced technologies in some sort of decentralized way. So you want to start a massive global scale decentralized grants program where you're giving grants to researchers and developers across the whole planet. Some are working on AGI, some are working on nanotechnology, some are working on biotech to cure various diseases and prolong life. And I mean, $1 trillion seems like a lot to you and me. On the other hand, after the financial crisis in 2008, Obama, materialized like $4 trillion and put it into the Federal Reserve and various big banks. Arguably that helped stabilize the U.S. economy, but it wasn't like a world-changing amount of money, right? I think sovereign wealth funds of Saudi and Norway are more than $1 trillion now, for example. But still, curing world hunger and multiplying the research budget for random unaffiliated researchers around the world to build amazing advanced technologies, it would certainly be a good thing. So yeah, I'll be happy if your viewers contribute that, and we can do it. I'm ready to go.
I have what you want to leave behind in this world. Why are you doing what are you doing, and what you want to?
I don't want to leave behind anything. I want to live forever and keep enjoying it, right? And I think I think we can do that. I mean, I'm 56. I think we're 1 or 2 decades away from being able to obsolete aging and death. That's one of the things AGI will be able to do. But I mean, clearly, as well as leaving behind a bunch of human children and grandchildren, which is probably the most gratifying thing at a sort of heart level. I mean, I'm aiming to contribute to creating beneficial artificial general intelligence, and I mean that's not something one person will do. It's something that will be done by a large network of people. But I'm aiming to contribute to that, and I think if we can make the first AGI worthy of the name, good-hearted and compassionate and beneficial toward humans, I mean, that has all sorts of amazing follow-on effects. So I'm aiming to contribute to that as best I can.
So you don't want to die?
I have no desire to die. No, do you?
Oh, I don't care, actually.
Well, would you like to die in the next 5 minutes?
It would be exciting to see what is on the other side.
Well, what if you could make an exact copy of yourself, let one of them die and see what's on the other side, and one of them stay here? Would you prefer that?
Yeah,
Yeah. All right.
Yeah.
Well, we may have that. We may have that technology in just a decade or two also, right? Because I've often thought, like, if you fuse your mind with a super AGI, in a way, that's a form of death, right? Because you're going beyond the human self, and you're going beyond the illusion of will and self and individuality. It's a form of death by merging into some superhuman God mind. So that, which would be very fulfilling, but it'd be also cool to have a copy of yourself that just remained a human, but without having to get old and die or get a headache or a stomach ache, right? But once we enter an era of abundance and post-singularity technology, it doesn't have to be either or. But I would say you're very young. So I think when I was in my early 20s, I also felt like I didn't care. In your 50s, the prospect of getting old and dying becomes more real, and then you start to care. So it seems to me the way the human body is programmed.
Okay, so the way that we end this podcast is I give you 30 seconds, and this is, imagine you are going to die in 30 seconds, and this is your last things that you are going to broadcast to the world, to your children, and I'm curious to see what you are going to say. Are you ready?
Sure.
Time starts now.
So this is not for my children who don't need a 30-second message from me, but for the rest of the world. I think we're now at an incredibly critical point in the evolution of humanity and intelligent life in our region of the universe. We're about to create human level and then superhuman thinking machines for the first time. If we make these human level thinking machines compassionate and benevolent and good-hearted, all sorts of amazing things will follow on from that. That's unfortunately not the only possibility. What we need to be doing now is, putting all of our hearts and minds into the problem of shaping this next generation of intelligences in a compassionate and benevolent way. And you don't need me to tell you how to do that. We all need to be figuring out how to do that to the best of our own abilities and with our own insights and backgrounds.
Thank you for watching, guys. We love you.